This was number 1 on the 2013 free response. I would say that this was probably the hardest one just because of Part C and Part D when we get there, that you kind of have to define your own function for the amount of unprocessed gravel, so that one was a little tricky. But what we have with this one was a gravel plant, and we have unprocessed gravel arriving at a rate represented by capital G of T, and it's important to note that this is a rate. It's the rate at which the gravel is entering the plant and it's unprocessed, and they process it there and ship it out. We're doing this over an 8-hour work day, and when the day has begun, there's already 500 tons of gravel at the plant. So during the hours of operation, what happens is they're processing it, and it's at a constant rate of 100 tons per hour. So that's kind of the rate at which, you know, we've done these before. We did it with the Valley Fair problem, or the amusement park, where people were coming in and people were leaving. We did it another time with, I think, oil going in and oil going out. And so this is the same type of situation. I don't like it as much because you're not as familiar with like a gravel plant as you would be with an amusement park, and that kind of hinders the understanding of the problem, but we'll work it out. For Part A, that one shouldn't have caused you any problem. I'm trying to find the derivative at 5. So what I would have to do is, this would have been a Math 8 problem where you go do your derivative of G of T, and we would have done that, you know, on your calculator, that would have been x squared over 18 instead of the t. And although we're doing it with respect to time, again, on your calculator, we do that with respect to x, and we would have done that when x equals 5. Okay, so basically you're just doing the derivative of the derivative. And when you do that on your calculator, I'm not going to bring up my graphing calculator, you end up getting negative 24.588. Hopefully that rings a bell for you. And this one does say to use correct units. So this was already a rate in tons per hour. So when I do the rate again, I basically get tons hour per hour. You could put tons per hour squared, anything like that. So my guess is this probably would have been 2 to 3 points. They haven't released the solutions or the scoring guidelines yet. So I'm not really sure about the point distribution, but 2 to 3 points for that. 1 for sure for the answer here, and I would think 1 for the label, and then another one, if you notice within the question, it says to interpret your answer. So what this basically means is that the rate at which the unprocessed gravel, and I'm sure you don't have to be that specific, is arriving. So it's basically the rate at which the, oops, I forgot a word, the rate of unprocessed gravel is arriving is decreasing by about 24.588 tons per hour squared, or per hour on the 5th hour, or you could say at t equals 5. Now I don't know if you need to be that specific. You could have put the rate at which the rate is decreasing is 24.588, or you could have put the rate at which the rate is changing is negative 24.588. They basically just, I think, will be correcting that you did the rate at which the rate is changing. So that was Part A. I think that would be 2, maybe 3 points for that one, and that one was very straightforward. For Part B, find the total amount of gravel. So remember, when we're going from tons per hour back to tons, this is an integration, and they just want that arrives, and this is given the rate at which it's arriving. So I don't need to do anything weird here. I just need to integrate over the course of the entire day the rate at which the gravel is arriving, and that'll give me the total tons of unprocessed gravel that arrive at that time. And when you do that on your calculator, you ended up getting about 825.551 tons under a Math 9 option. And my guess is that's probably only 1 point, maybe 2, Again, I'm guessing at point distribution, I'm not really sure. So even if you just got those first two, you're at about 3 to 4, probably, around the national average right there. Part C and D for this one I thought were the hardest two to get your brain around on the entire free response. Mainly because they're asking you for the amount of unprocessed gravel at the plant, and there is no function explicitly given for that, so you kind of had to think that out. Now you can do this with calculus. I'd also say you could have done it with some common sense. I don't know if that's as accepted point-wise, so I'm going to go through it with the calculus, and then I'll insert a little common sense into it also. So I don't know, what's called the amount of unprocessed gravel, I'm going to call it just A of T, and I'm going to say that that's the amount, and it's actually the total amount at the plant, and you wouldn't have had to lay this out, I'm just doing it for you. So A of T equals the amount total of unprocessed gravel. It's not the amount arriving or the amount leaving, it's the total amount at the plant at any given time. So if we think that out with a little common sense, and get an actual function defined for that. Remember, there were 500 tons before the workday even started. Then it was arriving at a rate of G of T. So when I integrate G of T during the course of the day at any given time, that'll give me more unprocessed gravel. So what I've got here is all the unprocessed gravel during the day, but remember it's also leaving at a constant rate of 100 tons per every hour. So this would kind of give you the total that you have. And again, you had 500 there to start with. This is the accumulated unprocessed gravel, and then this is the rate at which it's being processed. So that's my function for the amount, and it wants to know whether it's increasing or decreasing. Well, for a function to determine whether it's increasing or decreasing, we need to take its derivative. So really what I'm looking for is the rate of change of this function. Well, this constant doesn't matter, which kind of makes sense in the context of the problem. Whether it's increasing or decreasing, it's not affected at all by the amount it started with. For example, in the amusement park problem, if there were already, say, 300 employees at the park, and then it tells you how many people are coming and going, the rate of change in people at the park is not affected by this constant that it started with. All right. So now again, when I'm doing the derivative, remember when you do the derivative of the integral, they undo each other. So I really just get G of T there. You can kind of think of dump and derive, whatever you like, but I'm taking the derivative of that, and then minus 100. And this wants me to do that at 5 hours. So really what I'm doing is I'm figuring out how much gravel arrived at the plant, and then how much is leaving the plant at 5 hours. And that's where the common sense approach could have come in, I think. I think that you actually could have gotten away without setting up the calculus, and you could have just said, you know what, the amount of unprocessed gravel arriving at the plant, the rate at which it's arriving, is G of, in this case, G of 5. And if you go do that on your calculator, I'm not exactly sure what you get, and then subtract 100, you end up getting a negative number, and I'm not sure this is exact, but it's pretty close. A negative 1.859, and this would imply that it is decreasing at that time. And you could have gone and looked at your calculator and graphed this entire function, and you would have noticed it was decreasing, but again, you can't use your graph as an argument. So you needed to have some sort of a calculus argument where you actually define the function, take its derivative, find if it's positive or negative, and in this case it was negative. Or you could say the amount there at 5 was 98. That's what you get, about 98 is what you get when you do the G of 5. It doesn't, either way, I don't know if they would accept a common sense approach, so this is probably the safest. That was a hard question, I thought. All right. The next one up, only because they didn't define this function for you, but are asking you to use it. So this was kind of a good question here. Now, when it says a maximum amount of unprocessed gravel at the plant, again, maxes occur for part D. We'd have to consider all the possible candidates for here. The max will occur at the end point, so at 0, 8, or at any critical points. of the function? Well, my function again is the amount of unprocessed gravel at the plant. So I'm going to redefine that. How much unprocessed gravel is at the plant at any given time? The 500 that I started with plus the amount I accumulate minus the amount that's leaving. And again, I want to find the critical points of this function. So I really want to find where its derivative is 0. So again, when I go do the derivative, this gets dumped in. I really get g of t minus 100. Now, again, it's the rate at which unprocessed gravel is coming in minus the rate at which it's being processed. And it should make sense to you that my critical point is going to occur when they're equal, because otherwise I will be continually going down or continually going up. But once that they become equal, there's a switch there in the amount of gravel at the plant. So really what you needed to do on your calculator, I think the best part would have been, you could have either done this and done a calc 0, or you could have graphed this one and then graphed 100 and looked at where they intersect. And when you did that, it ended up being at about 4.923. It probably would have written the whole thing down here. I rounded to 3 decimal places. So then when you go do your candidate analysis over here, I've got 3 times I'm looking for. At the start there were 500 tons of unprocessed gravel. That was given to me. At 8, I would have put 8 into this function up here, the 500 I started with, plus integrating from 0 to 8, which you actually already did in part A. So, you know, it's probably acceptable to use the answer you got in part A right there, and then minus the 100 for every 8 hours. And when you did that, you ended up getting 525.551, which is really your, well, let's go to the next one. And then, likewise, when you go put the other candidate, 4.923, into your total amount function here, you end up getting about 635.376. And this then is the maximum amount of gravel. So you would say the maximum amount of unprocessed gravel at the plant is 635.376 tons. And I don't believe you'd have to say this happens at 4, because it just asks for the maximum amount. So those two were really tricky, I thought. I've got a little bit more time, but I think I'm just going to do a separate video for the next problem. So again, I think this probably would have gone 2 to 3, probably just 1. So maybe we've got to show work, amount, increasing or decreasing, probably 2, probably 3. What am I at? 5, 6, 7, 8, 9. Yeah, I think it would have gone probably like that is my guess. Maybe 2 on these two. So kind of think of what you got on those, and we'll do number 2 next.